fault tolerance, predictability, cost efficiency. That is what will define AI agents for the enterprise in the future. So let me first start with the introduction of the company. If you're not aware, JetBrains is the vendor of the professional IDEs, such as IntelliJ, PyCharm, and multiple others. But other than that, we have a JetBrains AI brand. So who heard about JetBrains AI? Okay, quite some people. Sounds good. So just a brief overview. So in JetBrains, we have created AI assistant in our IDEs. We also trained the Melu model, which is the best LLM for code completion in the world. And it's a local model, and it's open source. We also have AI agent called Junie. It's a fully autonomous coding agent, coding assistant that works in the IDE, and it helps you to automate coding tasks. And quite recently, actually like a few weeks ago or maybe less, we announced a Matter. Do you know why? Because every person in the development team matters. It's a collaborative AI agent environment in the cloud that brings in developers, QA, like product managers, designers, all to work together on the same products using AI agents. And most of our AI products, not only these ones, are based on Koog Framework, which is the combination of all of this AI experience that we have in JetBrains. And what did we learn from all of this experience? First thing is AI is not a solution for any problem. It's not a solution at all. Why? Because it's a tool. AI is a tool. And if you are enterprise, you already have much more advanced and important tools to build actually great AI agents. So some of them are obviously data access. Enterprises in the existing enterprise environments already have the access to lots of data and also functionality and connections. So it's really important, in my opinion, not to focus just on AI, but to focus on bringing this AI to where your enterprise already lives, to the stacks that your enterprise already operate on. And that is the key to success. So going back to my AI experience story that began in JetBrains, every AI experience starts with, obviously, AI experiments. And we all love AI experiments, but they have some limitations. First of them is you have fast iterations. You code something, you check if it works, you do it in your Jupyter notebook in Python somewhere, then you run it a few times, and then you get the results. Also, the maintainability cycle of such experiments is pretty low, right? You just do the experiment, get the result, and then you have to include it to your actual enterprise code base, right? And then it works somewhere in a notebook in full isolation from the actual products. And if it breaks, well, no one will die, right? No one cares. It's fine. There is a low risk if it breaks. But when experiments meet production, that's the whole another story. So first of all, most of the production workloads, especially the backend ones, are operating on the JVM, and some others are on .NET and Node. And it's, as I said, extremely important to bring AI agents to the stack of your existing AI applications, because they already have all of the benefits, all the data access, all the functionality access. And in production, you have quite a lot of maintainability requirements. You have to be able to read and reason about your code and refactor it and operate with all of that code that you produce efficiently. And you face a huge reputational and financial risks if something breaks, if something goes wrong. But what else? Apart from the stack, what else defines the enterprise AI agents? Well, the first thing that obviously comes into mind is predictability. Who loves prompt engineering? Prompt engineering is amazing But naive prompt engineering brings unreliable results. And don't get me wrong, like models are improving and prompt engineers are doing great work, great job. But you know, it's like you can write a really long essay how you spent the last summer and what you want to be achieved until the next winter. But at the end of the day, you cannot guarantee anything. You can only hope. And that's a problem, right? To illustrate if like it's really a problem, let's think of this example. The models are improving, and even if you manage to get 99% of correctness rate, is that really enough for deploying it on a critical enterprise application? Well, let's kind of think of this example from the business perspective. If 99% of the time is correct result, but 1% it leads to, for example, a customer churn. Not that bad, right? But given that each single run of AI agent is unpredictable, and if the first run was successful, it doesn't guarantee anything about the previous run, all of that customer churn rate, it actually compounds. So if you have 100 times returning customer, the churn rate will be already 63%, which is quite noticeable, right? And of course, that's just an illustration, right, of how important that is. So the next thing that is also important is fault tolerance. Why? Because, well, usually enterprises don't really like when something just breaks and stops working. Users start complaining, and there is a huge risk from the reputational perspective. But other than that, if your agent just stops running for some reason, for example, you have a bug in your application, or you're running that on the AWS EC2 instances, which are great for cost optimization reasons. That can, you are using the unused capacity on Amazon machines, which is cool, but at some point, Amazon can preempt your instance and rerun your process on another machine. So essentially, for backend application, because of all of persistence things that they have, it works. But for naive AI agent, it doesn't. So what does it mean? It means that your agent will have to restart on another machine from scratch. They will lose all the progress, and you will have to spend the same amount of money again to meet the same point. So if you add the recovery system somehow to that, you will save a lot of money. That is essential for enterprise. So, and for this, all of this and many others of the problems that we faced, we made a solution, and it's called Koog. It's an open source AI framework by JetBrains that allows you to build and run AI agents on the JVM. So you can run agents on the enterprise stack that actually you have in your systems, right? So Koog targets a JVM, natively Android, iOS, JavaScript, and WebAssembly. Same code runs actually everywhere, just thanks to Kotlin multi-platform. So it actually allows you to bring AI agents not only to the backend, but also to the edge devices, to the devices locally that your customers have, right? And it's actually battle tested on our own products of JetBrains. And it solves the real-world problems that we faced when delivering actual AI applications to millions of users. So to sum things up, Koog is created by the enterprise and for the enterprise. And let me list a few other problems that we solved. First of them is scalability. One of the issues that we faced when running actual agents at scale for a long time is that you eventually hit the context limit. Then you have to do something with that. And we built a solution for that. Like, we have pretty advanced and fine-tuned strategies out of the box for compressing the history and retrieving the facts. So you only have to use that solution and declare what facts are important, and then the framework will handle the rest. Also, you get the full control of the agent's behavior. I think this picture might be familiar to you. So in Koog, you can define the precise graphs of the precise workflows for your agent, and which steps follow after which other steps, and on which conditions you go to some other branch. And you can also compose the higher level components. I will show it later. So essentially, you can have subtasks or like sub-agents, but they are not independent. They all share the same history. And we have the solution for fault tolerance and for recovery. And last but not least, observability. Why else I would be here? We integrate with weights and biases with. I'll show you later. So for those of you who are developers, that's the very simple example of an agent built with Koog. It's in Kotlin. You can also do that in Java. So you just register tools. They are just functions of your existing JVM application. You define the agent, connect to OpenAI, define the prompt. For example, if you give the banking tools and you define the banking prompt, then it can solve banking tasks like sending money and something else, right? But that's not the real power. Much more powerful approach is when you define the strategy for the agent, and that's the Kotlin DSL for that. As simple as it is, that's the whole code that you need to write with Koog in order to get the workflow that you see on the right in the picture. Sorry, it's on the right. So essentially, you can define or like use predefined nodes like LM requests, calling some available tools, sending back the results, and then you can build the conditions and draw the graphs. But that's not impressive enough, right? Isn't it? So the actual, the most powerful thing that Koog provides is it provides the domain modeling out of the box. So what does it mean? You can define autonomous steps, autonomous sub-agents, or actual subtasks that are focused on a subtask of your overall goal, and it has a limited access to only required tools. But what is important is that everything in Koog is type safe, and it has a specified input data type and the output data type. Why is that important? Let me show it. So, oh, sorry. Just a second. Yeah, I think, my apologies. I think some slides have been corrupted. But essentially, let me just say it out loud. So you can define a data class which has all the fields required for the agent output. Like imagine like in the real life, when you're coming to a bank and you want to open your bank account, they don't just accept you, right? You have requirements. You have to bring your passport, you have to bring some other documents, and you have to fill in the application form. And unless you get everything required and you fill in the form, you cannot proceed further and open the bank account. That guarantees the success, right? And the same with domain modeling approach. So instead of writing everything in a textual prompt and hoping that it works, you can specify the data class, which is essentially the form that the LLM have to fill before it proceeds to the next step. It will like call the tools and do many other different types of work until the form is fully fulfilled, and only then you can proceed further. And that guarantees you the success, right? So naive prompt engineering can give you only hope. Domain modeling can give you the contract, the trustful guarantee. And you can actually program the data flow of your agent. The next thing that I promised is fault tolerance, and that's how you can do it in Koog. Imagine that you have AI agent defined somehow, and then essentially you can just install the persistence. So inside that persistence installation block, you just specify where to store the data, like in some database, and that's pretty much it. The magic will happen. So what will happen is Koog will checkpoint the whole state machine after each step of execution. And that's important. It will not checkpoint just the message history and tool calling history. It will checkpoint the exact place in the algorithm. And then, when the application is crashed and gets recovered, it will start from the same place in the algorithm, the same place in the state machine. And moreover, Koog allows you to roll back in time, and it also allows you to specify the rollbacks for any side effects in your database, because when you roll back in time, you already have the database messed up, and Koog can handle all those problems as well. So that's the illustration how it works. So you have a strategy graph, like with a few steps, and somewhere in the middle, that's where the execution is happening right now. And what Koog does, it saves the place of the execution, the exact node, and all the other types of state, including the message history, including the metadata, and many other things. And then it recovers right from there. And the last feature that I would like to demonstrate is observability. Same way you just installed and added persistence to your agent, you can install OpenTelemetry, and inside we provide the out-of-the-box Weave integration. You just provide the credential to your Weave instance, like API key, the entity, if you have a self-hosted one, and the project. And then you can open the Weave console and observe what's happening in your agent execution. So if you actually zoom in, which I couldn't do it here on the slide, you will see all the steps and the nodes throughout your graph, what happened in the agent, and you can reason about the execution. So essentially how it's done is Koog sends all the events like LLM requests, strategy steps, and other types of meta information to Weave console. And then you can open it and discover why the agent ended up here and how much you spent on each step. So together with Koog and Weights and Biases Weave, you can build not just funny demos, but trustful systems that are predictable, scalable, enterprise-ready, and explainable. And just want to share a few notes from the community. So we launched Koog quite recently, like less than 5 months ago, and it's gained already 3.4K stars on GitHub, mainly from the JVM community. And we got quite a few important notices from the likes of Docker, which, by the way, played a very funny analogy of the Koog name, like in the Ratatouille cooking cartoon. And Mercedes-Benz, for example, who are openly speaking on public conferences about using Koog for building AI agents. And if you want to also be part of this community, try Koog today and cook your enterprise AI tomorrow. Let's stop building funny demos and start building production-ready systems. And thank you so much for your attention. If you have any questions, feel free. Please.